Hello, we were working on chapter 5, section 1, trying to identify linear functions. In the previous video, we talked about if I see a graph, can I tell if it's a linear function? Another way to describe a relationship or a function is with a table. So we're going to talk about whether or not these are going to represent a linear function. So I'm going to write it down here at the bottom. Here's what I'm going to look for. I need to find the difference, which is what I get when I subtract, of the y values and the x values. And when we're doing this, we're talking about what we call the first difference. Later we'll do the second difference. We'll talk about what that means. It doesn't make sense right now, but we're only going to find the difference first, okay? So we're going to find the difference by subtracting of the y values and the x values. So, and I put them together, and I just realized that I don't want you to think I mean like y minus x. And what we're talking about is how do we go from one to the other, all right? So if the change in y and the change in x are constant. So you always get the same difference for the y's, and you always get the same difference for the x's. They can be different from each other. That's one of the things that I got to catch myself as I'm making the video, because I'm trying to anticipate what you'd be asking. If the change in y and the change in x are constant to each other, sorry, to themselves, I suppose. I don't want to say that. Then it is linear. So much easier if I explain it. All right, so let's look at the x's. And I know these are written vertical. We don't have to write them vertical. We can write them horizontal. It doesn't matter. But I'm going to be going from x to x. I'm just looking at the pattern. And this one goes -2, -1, 0, 1, 2. It looks like every time it's going up by 1. And that is constant change. And there's a symbol that we're going to use for this. It's a triangle, but it's actually the Greek letter delta, okay? Delta. And delta is used in math and science to mean change. So the change in x, or delta x, is going to be +1. Now let's look at the y's. Going in the same direction from top to bottom. 7, 4, 1, -2, -5. So to go from 7 to 4, I'm going to go down 3. To go from 4 to 1, I'm also going to go down 3. From 1 to -2, still down 3. And from -2 to -5, I'm still going -3. The change in y is going to be -3. So since this stayed the same to each other, all of them are 1s, and these are all -3s, we say yes, this represents a linear function. It's a table of possible values that fit a linear function. Let's look at the second one. So I still have -2, -1, 0, 1, 2. So that's nice. And to be honest, usually, since x is independent, we get to choose those. So usually we choose them in a nice way. And these are still all +1. So the change in x is still +1. But now let's look at the y's. To go from 6 to 3, I'm going to go down 3. To find, when we call this the difference, what you would do is 3 subtract 6, which equals -3. To go from 3 to 2, that's down 1. To go from 2 to 3, that's up 1. And to go from 3 to 6, that's up 3. Now it looks like there's a pattern here, but there is no constant change in y. So this is not a linear function. It might be something else. And if we ever come back this way, I can actually tell you what this is after we do the quarter 3 stuff. But for now, all we're trying to figure out, is it linear or is it not linear? Find out what the differences are. If all these are the same and all these are the same, then it's linear. If either one of them, see, notice how all these were the same but these were not, then it's not linear. Let's do a couple more examples. And of course I'll do more problems from the back of the book. All right, let's look at 2, 5, 8, 11. So they messed it up a little bit for us. They mixed it up a little bit for us. To go from 2 to 5, I'm going to go up 3. 5 take away 2 is 3. 8 take away 5 is also 3. 11 take away 8 is also 3. So my change in x equals up 3, or positive 3. Let's check out the y's. From 4 to 3, it's going down 1. Still goes down 1 to get to 2, and still goes down 1 to get to 1. So 4 minus 1, 3 minus 1, 2 minus 1. My change in y is negative 1. So yes, this is a linear function. Finally, for the last problem we're going to do in this example, negative 10 to negative 5 to 0 to 5. This is up 5. This is also up 5. And this is also up 5. So negative 10 plus 5 equals negative 5. Negative 5 plus 5 equals 0, and 0 plus 5 equals 5. So my change in x is going to be plus 5. For the y's, 10 to 4 is down 6. 4 to 2 is down 2. So already I know those two have to be the same. So I already know it's not a linear function. Even though go down 2 works for both of these, all of them have to work. So there is no constant change in y. So this is not a linear function. Okay, so after doing 4 examples, maybe by now you're starting to get the hang of it, but we will, in one of the other videos, I will do a couple more examples. And we'll also show examples where you have to write the table from what they've given you. Okay, we'll see you.